Welcome to this webinar on midas Gen and BIM. midas Gen, what is it? Okay, it's a multi-material analysis software. It covers both British Standard and European codes along with a wide range of other international codes. Multi-materials, so timber, concrete, steel, etc. can all be analysed within midas Gen. BIM, big subject for 2015, with all projects hoping to be using the BIM side of things for 2015. Where does midas Gen fit? Well, it fits with the structure engineer and has a direct link with Autodesk Revit, so we can take things direct from the architect through Revit into midas Gen using the external tools export function within Revit. Let me show this in a bit more detail by opening up a Revit model. You can see here the Revit model, which has come from the architect, or perhaps you've used it by the structure engineer. This is actually in Revit structure. If we go to the external tools function, you'll see a direct link. Select that, export to midas Gen, and then what happens? Okay, it comes straight through into midas Gen. Everything comes through: shear walls, slab openings, all the section properties come through, as we can see on the left hand side in the works tree. No data's lost. Probably the most common way that people are still modelling is by using DXF files or from AutoCAD. So let's have a look at this way. If we go to midas Gen, we have an import function. Go to File, Import, and then DXF. It now asks us to locate that DXF, and it shows us all the layers that are available. So you may just wish to export a couple of these layers, or you can bring them all through. So let me select them all in this case. And you can see again our entire model comes through. Again, on the left hand side, a few of the details have already been defined, so we quickly select some concrete and some steel there or there. All the layers are there, and the layers actually work as groups. So for example, if I select the foundations layer, I can quickly assign strip foundations by dragging and dropping some concrete details in. Again, with foundations, they're obviously not always strip foundations. We have a few pads, so let me apply a couple of them. Or similarly, we may have a mass concrete slab, which in this case we'll assume we've got under the shear wall. So let me select the shear wall, select that in isolation, and again let me just put a slab in. Select the concrete that you want to use, a thickness, and when we're happy, select apply, and you can see that it's automatically meshed out for us as a slab. So there's a few different ways that we can assign things. We can either by layer. So in this example I can select by layer again, and this time I'm going to look at the shear wall. When you've got this open, you can also select things in plane. So if you wanted to select an XY plane, you can indeed. Let me do this for the shear wall, and it finds everything within that plane. Again, let me apply some concrete and a thickness, and select apply, and it will start to build up this wall. Let me do this for the other sides of the wall. And toggle back to the model, and we can see quickly within a few seconds we're starting to build our model together. Again, we now need to put a floor slab in, so let me select it via plane again. Select it in isolation. Obviously it's selected everything at the moment, so we now need to deselect obviously the shear wall. So you can do that via window, or you can do that by selecting individual elements. And once we're happy we've got the area we want to actually mesh, again define the slab thickness, select apply, and we've now meshed our slab. Things like columns, we can select this via window, the beams, etc. So in this case we're going to have some steel beams. Let me select those. Back to the material section database, and I can quickly drag and drop them in, and that's that updated. Again, I could do that for the bracings, the columns, etc. They're all available. I need a few other walls in here, a few other slabs in here as well. So let me make them concrete as well, and put in the other columns. The timber roof, again select the areas you want to. You can see it's quickly defined all them and located them. Again, I'm just going to drag and drop some predefined details. There is a complete database on these, but if you have got something irregular or unusual, you can define your own sections in midas Gen. Let me put these last couple of slabs on, and that should be our model ready to go. Okay, so we've now built our model. We now need to start to define a few other details, so we need to apply things like loads and boundary conditions. So loads and boundary conditions, you can apply a wide variety of loads. In this case I'm going to assume there's a basement, so let's start at the bottom and let's put on assume this is a retaining wall and put on an earth pressure load. You can put in hydrostatic loads here if you wanted to. Let me just select a few of the soil details. Again, if you've got an SI on your desk you can apply that. You can see that it puts the trapezoidal load in for you, so that automatically derives that, just saving you time. Again, we obviously need to apply a force to the slabs, so let me select that by plane. Now it'll automatically define self-weight for you. In this case I'm just going to put a continuous floor load on there, a dead and a live load. Let me apply these. Again, as I said before though, patch loads, line loads, you can put all of them in if you wanted to. We can put soil interaction in there as well. That's an inbuilt function, so it'll automatically define the soil springs, the interaction between the foundations and the soil, just a few clicks of a button. Again, if you've got an SI you can refine these details further. So that's all the boundaries assigned and the loads assigned. We now obviously want to start to look at the design of it and the results of it. So at the moment let's look at a few of the results. We can look at things like bending moment diagrams. Simply select what we want to look at here on the left hand side. You can see that they're defined. You can also see the actual geometry of the model in the background. You can turn this off if you wanted to make it a little bit clearer, which I'll just quickly do so. And it looks a little bit neater. Again, if you want to look at plate stresses, we can do that for within the concrete. And we can also start to look at the slab details and column details. So let's have a quick look here at the deformed shape, and then we'll look at the slab. Again, exaggerated view of the deformed shape. Let's look at the slab quickly, going into the design side of things. And the columns. So select what we want to look at. So in this case, what we're going to start with, let's start off with the reinforced concrete column. Select a few on the ground floor here, and select the concrete column designer. Now it's going to bring you up a one-page summary. You can have a more detailed report if you want. You can even bring up 3D interaction curves if you so wished. The same is available for steel columns. Select the steel members that we want to have a look at. You could again select them by layer if you wanted to, or select them by isolation. In this case I've just selected a few in isolation, so I've selected a couple. Go back up to the design, this time select the steel, and again we can see a one-page summary of that section that's been chosen. Looking at the slab now, we can let me just isolate the slab a second. Choose it by plane. We can now ask it to design the slab for us. We've already put some details in, but now we want to ask it to say perhaps use H10s, and it will find us the reinforcement mesh for that. So let me just quickly define that. You can see the contour plot there of the reinforcement diagrams. At the right hand side it's annotated, and you can put this by letters, so you could define these by areas. We can also start to look at punching shear checks around the column heads. Let me have a look at those. You can see they're defined. If you wanted to look at the increased reinforcement around these, we can of course do that. Simply select it from the drop down menu on the left hand side, and it will bring us up that plot. So this is an automatic design function that's available in there. You can obviously take more manual control over it if you wanted to. If you want to do the same for wall design, simply select all the walls. I've done that by just find the wall properties and ask it to automatically define that, and it has. You can see where the increased reinforcement is required. Dynamic report generation is a really powerful feature of Midas Gen. What it is it's a report that will constantly update as you revise the model. So simply select the dynamic report function on the right hand side, and it opens up a Microsoft Word document, and that's embedded within Midas Gen. In here you can type away, you can annotate any diagrams you wish to bring in. So let me just quickly type something. Then we'll go back to the model and select an image. We save the image away, So it may well be a result, it may well be the geometry, anything you're after. Save it away, go back to the worksheet on the left hand side and select the report function, and then we can just drag and drop it in. Again, tables, they're 100% compatible with Excel, so you can import and export through Excel. In this case I'm just going to copy and paste a table of some reaction forces of the columns. So let me go back to the model. I select a few columns I want to look at. So let's look at these steel columns here and the concrete columns there. Go to results again, and this time I'm going to look at them in a tabular format. Interesting to say that when they're in a tabular format you can sort them if you wanted to, so you could filter these. In this case I'm just going to copy the whole lot out. Back to my dynamic report and paste them in there.